going to run through 4 examples of some more sum and difference, but they're going to look a little different for the most part. So what we have here is I already have, we're just working backwards. We have the identity stretched out. We just want to figure out what's going on here. So I have alpha and beta as 25 and 15 degrees, and we're just going to match on our trig identity which one of these goes to. And we don't do a whole lot of this, it's just an exercise. And you're going to find this is nothing more than the cosine of alpha plus beta, all right? Because you have your 2 cosines here, your 2 sines here. That should clue you in you're dealing with a cosine. It's just don't know, you got to just determine if you're adding or subtracting, and that's flipped. So this is nothing more than cosine of 25 plus 15, which is the cosine of 40, and that's it, okay? Again, we don't do a whole lot of this. It's just an exercise to help memorize the definitions for the most part. We could do the same thing for sine and tangent. And again, you know you're dealing with a sine because of this relationship right here. The question is, are you adding or subtracting your sines? Well, if you look on your formula, you're going to be adding, all right? So this is nothing more than alpha and beta, all right? So let's go ahead and do sine of 140 plus 50 is equal to the sine of 190. Just working backwards. Simple little exercise. Nothing too big. All right, but these get interesting. They're actually kind of easy. They just look very intimidating at first. We're going to find the sine of x and y based on the fact that sine of x is equal to 5/13, cosine of y is equal to negative 3/5, and it's very important I tell you what quadrant they're in. It's a very hard problem to do. Actually, you can't, not with any accuracy, of what quadrant you're in. So let's go ahead and sketch. Let's do my sine. Let's do this a little bit better. Okay. I just think too much when I draw. Yeah, well, whatever. Okay. So here's my sine in quadrant 2. Here's my alpha, if I want to, or my x, since I'm given x. And sine is opposite over hypotenuse, so this is 5/13. This is a 5, 12, 13 triple, but this length is negative 12. So we got to know that. We have a coordinate, x is negative, y is positive. The coordinate is negative 12 and 5. Okay? So what we're going to do is take a look at our cosine one, also in quadrant 2. And cosine is adjacent over hypotenuse. And this is a 3, 4, 5 triple. So now we're going to go back to our sum identity of sine. And if you remember that, they bounce back and forth between sine and cosine. So you're going to have sine of x, cosine of y. All right. So, sine of x, here I'll just write it out. Sine of x, cosine of y, all right, plus cosine of x, sine of y, all right? And we're going to substitute in. So sine of y is nothing more. Here's y over here, okay? Sine of y is just 4/5. So we're going to put in 4/5, all right? I'm sorry, that's an x. X, all right, there we go. Sine of x, x is right here, is 5/13. All right, so I'm going to put in 5/13. And then cosine of y is negative 3/5. We're going to add cosine of x, negative 12/13. And the sine of y, well, over here is 4/5. All right. And I'm going to simplify. Well, actually, I'm going to avoid simplifying because I see patterns when we do these triples. We have 5 over 5. I can simplify that as 1, and I have negative 3/13. But I'm not going to do that. I'm going to multiply straight across, and it gives me negative 15 over 65. Because look what's going to happen over here. I got a negative 48. All right. So plus a negative 48 over 65. So that's negative minus a negative. So that's going to be negative 63 over 65. And that's my answer. Let's take a look at another example. So now we're going to do cosine, and we're subtracting. So you look on your identity and figure out which one that's going to be. It's going to be cosine x, cosine y, plus sine x, sine y. But let's go ahead and draw our little sketch over here. Let's do sine of x. And we are in, quadrant 2 again. So I'm going to do this. All right, 5, 13, and negative 12. So nothing too exciting. We've seen this before. And my y, this is y and this is x, is going to be negative 3, 5, and 4. Not too inventive. We could have done other things. So let's go ahead and I'll just write out the formula again. So cosine x, cosine y. And we're going to add, and it's the sine's turn. All right. And let's just go ahead and plug in cosine of x. Here's x. It's negative 12 over 13. Cosine y, right over here. So that's adjacent over hypotenuse, so that's negative 3/5. I'll put in negative 3/5 in parentheses. We're going to add sine of x, opposite over hypotenuse, so that's 5/13. Okay, 5/13 times sine of y, which is 4/5. Alrighty, 4/5. And again, I'm not going to simplify. All right, that's a 13 there. So I'm going to multiply straight across, and that gives me positive 36 over 65. And that's going to be a plus, so that's going to be 20 over 65. And that's equal to 56 over 65. All right? So you want to practice these, all right? That's equal. So practice these absolutely. Okay, moving on. I think that's, no, we got one more. Okay, so we're going to do this one. I guess we can. I think we've already done enough of these. I'm at 7 minutes, and it is, I got to get going. Alrighty, so basically we do the same thing. I could set it up for you real quick. So since we're doing sine of x minus y, you know what that's going to be. And you would just simply, seems like we just did this one. All right, so we're in quadrant 2 again. Yeah, we just kind of did that. So 5 over 13 and negative 12. All right, and so on. Wonder why it repeated. Oh, it's a minus, but it just changes the sign. We've done this. I'm going to go ahead and let you go, and I got to get to a meeting.